Click the bell icon to get latest videos from Ekeeda.
Hello guys, in this particular video we will learn the mathematical analysis on CS-CS multi-stage amplifier. The question arises in the form of to find out the value of voltage gain, input impedance and output impedance. So as far as CS-CS is concerned, we have to deal with field effect transistor where your current gain is infinite. So there will not be any question about what is the current gain. So basically you just have to calculate the three values. First is voltage gain, input impedance and output impedance. So let's come to the circuit. Circuit is consist of two stages. One is of CS and another is also of CS type, common source type. So let's look at this particular values. Values are not given in your circuit directly, given in the form of the resistances. R1 and R3 are same, having value 82 mega ohm. R2 and R4 having same value 8.2 mega ohm. RD1 and RD2 for both the stages drain resistance is 1K8. Here you should note that 1K8 is not a printing mistake. 1K8 means 1.8 kilo ohm. Okay, RS1 and RS2 is 680 ohm, which is having low value. Then GMO1 and GMO2, which is given as 5600 micromho. VGS1, VGS2, which is given as minus 1.2 volts. Output resistance, which is given as infinite, that is the ideal case. VP1, that is pinch off voltage for stage 1 and stage 2, which is given as minus 4 volts. So according to all these values being given, we have to find out the voltage gain, input impedance and output impedance for two-stage CS-CS multi-stage amplifier. Now let's proceed further how to go through step by step, right? So first step will arrive with DC analysis. So when we'll deal with the DC analysis, first of all you should note that why we are going for the DC analysis, as we want voltage gain. Okay, we want voltage gain, that is nothing but AV. So voltage gain depends on the value of GM, right? And GM we will get by using DC analysis, right? So that's why we are dealing with DC analysis. So each and every value is dependent on each other, so we have to calculate the first value and then we'll move step by step. So let's see for JFET, as both the stages are of JFET, we don't have to worry about the how to calculate GM1 and GM2. Both the values will be same, as GMO1 and GMO2 are same, and all the values of the resistances are equal to each other for each stage. So GM is equal to GMO into 1 minus VGS upon VP as per the formula of JFET, and just fill the values. GMO is equal to 5600 into 10 to the power minus 6, that is nothing but micro. 1 minus 1.2 is the value of VGS, minus 4 is the value of VP. We'll just put the value, get the answer, check your calc is working or not, and then again come to me, check the values you are getting 3.92 or not. 3.92 millimho. So GM is equal to 3.92 millimho, right? So I can determine that for both the stages I can conclude GM1 and GM2 is equal to 3.92 millimho. So that ends your DC analysis. You don't have to worry about the Q point because that is not been asked in this particular example. So let's move further for the calculation of the voltage gain, input impedance and output impedance. So let's move. Here is your AC equivalent model that we are looking for. Keep this in mind that whenever you are starting the step of AC analysis, you have to write the all coupling capacitors and bypass capacitors getting short circuited, or DC sources are getting short circuited, so that examiner will get to know that yes, this guy is well known about this particular concepts of AC analysis to form AC equivalent model. So this particular AC equivalent model is based on this particular concept, that is all DC sources are short circuited and all coupling and bypass capacitances I have to short circuit. So once I do this, I will place all the resistance according to the terminals. So here is source 1, here is gate 1, here is drain 1, here again drain 1 is connected to gate 2, then source 2, and here is drain 2. Okay, the beauty of this complexity of this particular circuit is 680 ohm and 680 ohm are there in the AC equivalent model because your bypass capacitances are not there into picture. Okay, so there will be some change in the gain factor, right? So how to calculate the gain? We'll just apply the formula and we'll get to know that how we'll get the value of AV1 and AV2, and the product of AV1 and AV2, that will be value of voltage gain. So in the very simple manner we will solve this particular problem. We'll say that if you want to have the complex, if you have the complex problem, then what we'll have to do, we'll just have to apply the KCL over here, and from this all analysis we'll jump from VO to VI, so that we'll get the value of ratio of VO divided by VI, and that is nothing but the value of voltage gain. Here we don't need to go for that analysis. We just have to have the formulae based on CS, that is common source amplifier. So for each and every value of voltage gain of stage 1 and 2, we'll have to calculate the value of AV1 and AV2. So let's see, voltage gain is AV, right? And I can say that the value of AV is equal to AV1 into AV2, whereas AV1 is for stage number 1 and AV2 is for stage number 2. As both the stages are identical, but hold on, the output resistance of stage 1 is connected in parallel with the input resistance of stage number 2. So whatever gain I'm getting at stage number 1, that will not be equivalent to stage number 2, mind well. So we have to calculate it separately. So what will be the value of stage number 2? First we'll have to calculate. I know that this is with unbypassed capacitor at the source terminal, so there will not be any capacitance into picture. Rather than that, in another sentence I can say 680 ohm is there into picture of your AC equivalent model, so you have to incorporate this 680 ohm. Okay, so now we'll have to calculate the value of voltage gain, that is AV. As I know that the voltage gain AV is equal to AV1 into AV2, whereas AV1 is equal to voltage gain for stage number 1, voltage gain for stage number 2 is AV2, and you should note that though the stage 1 and stage 2 are identical to each other, I cannot say that AV1 is equal to AV2. There will be some slight change in AV1 and AV2 also. This is because whenever we are considering the value of AV2 with unbypassed capacitor, then I can say that for unbypassed circuit, your voltage gain will get reduced by factor 1 plus GM-RS2. So I can say that your output stage ka voltage gain, that will become minus GM into RD2 divided by 1 plus GM into RS2. So that value comes out to be, if you calculate this particular value with your calci, just check the values, that value comes out to be minus 1.925. This value will be for stage number 2, that is AV2. Now if we check the value of AV1, that can be slightly different than that of your AV2. That totally depends on the value of RG2 that I'm putting for the stage number 2, right? So let's see, GM into parallel combination of RD1 and RG2. So as we get to know that in the AC analysis equivalent model, this RD1 and RG2 are both parallel to each other, so we have to incorporate both the resistances. I can say RD1 parallel to RG2, that I'll have to calculate, multiplied by GM, divide by the same factor 1 plus GM RS1, as RS1 is same as RS2, the denominator factor will be same. Okay, so here there will be slight change, we'll be getting 1.9244. Okay, so if we multiply these two values, we'll be getting the value of voltage gain, that will be the total voltage gain for multi-stage amplifier. So just have the product of this 1.925 and the value minus 1.9244. Here I'm not getting the much change. This is because your RG2 value is 82 mega in parallel with 8.2 mega, that is a very high as compared to 1.8 kilo ohm, that is RD1. So parallel combination is near about RD1 and RD1 is equivalent to RD2. So that's why near about same value of voltage gain I am getting for the stage 1 and stage 2. So let's have the product of these two values. We will be getting the value as 3.7045. So your value is 3.7045. that is the expected value for your multi-stage amplifier. So we'll say that your first finding is with me and I'll give you equation number 1. Let's move to the second finding. Here I can say that this is your equivalent circuit, and as I mentioned that as when we are going for the JFET, your mathematical calculation will become simpler than that of your BJT calculation. So if you are going for the input stage, this is open circuit that will help you for the calculation of the input resistance in more simplistic manner. So Ri is equal to Rg1, I can say. So Rg1 is nothing but the parallel combination of 82 mega and 8.2 mega, right? So that is in mega only. At the output stage, we will be getting only one resistance will be responsible to get the value of the output resistance, that is Ro is equal to Rd2. So here no formula, nothing else, you just have to put the value, get the answer, you will get the value of input resistance and output resistance. So here only we'll write the input resistance and output resistance. So as far as this circuit is concerned, resistances will be same as impedance. So input impedance and output impedance will be same as input resistance and output resistance. So Ri is equal to Rg1 is equal to 82 mega in parallel with 8.2 mega. We haven't yet calculated the value of 82 mega parallel with 8.2 mega. That comes out to be 7.4545 mega. This is very huge value. So as far as amplifier is concerned, that is idealistic input impedance I'm getting in terms of higher side. So at the output impedance, as far as output resistance is concerned, we directly have the value of output resistance. We can say Ro is equal to Rd2 and that is equal to 1.8 kilo ohm. That is a very less as compared to your value of input impedance. So this is nothing but the value of input impedance and this is your value of output impedance. So far we have got these three values which are expected in this particular numerical. In few next numericals, in the next numerical we will learn the low frequency high frequency analysis for the same CS-CS multi-stage amplifier. So stay tuned for that. Learn more and more EDC with me with Ekeeda videos. Subscribe channel of Ekeeda videos for all the technical aspects. Thank you so much.